Hello, so this is just a simple tutorial of plotting some data using Excel. So here we have some data, x1, y 2.1, x2, then y 3.8, x3, then y 3.5. We want to create a little plot. So let's select the cells, then we go to Insert. Here we have recommended charts. The order of these things might be different, but what I recommend for this kind of data, I'd use a scatter plot like that. So now we've fitted. Now we have the data plotted, and we can kind of move the plot around, put it in the right position. So for the analysis of Hooke's law, the equation is force equals spring constant K times extension X. So force should be on the y-axis, extension on the x-axis. Then the slope, you notate by the ways that Matthew talked to you. You can actually get Excel to do it if you click on the one of these lines. If you add a trend line, this will give you what's known as a fit. It gives you a line of best fit. I mean, essentially, it just puts a straight line from it. If you want to figure out what the equation is, you can put on. So it's a bit small. Let's see if we expand it out a little bit. So when I have this display equation on chart, this gives the equation x equals 1.975x plus 0.0333. So the slope or the gradient is 1.975, and that's the way you can get the spring constant, 1.975. I'd also recommend you check the slope as well, just to make sure I've not made any errors by looking at sort of delta y, change in y divided by delta x, which you did in Matthew's course. Okay, and just for information, so this is a way to what we call in the jargon fit a straight line to some data. There's also this thing called r squared. Okay, we're not going to use r squared in this course, but just for information, for this type of fit, this r equals 0.9936. This is something called the quality of the fit. So if you have data that is not like a straight line, this r squared will be very, very small. But if the fit is reasonable, or so if the linear is a good description of the data, this r squared should be close to 1, as it is here.